Welcome, everyone. I am Susan Sons, and I'll be emceeing the plenary today. I am an analyst at Trusted CI and also Deputy Director of Research SOC, and I'm here to introduce your first speaker, Rob Beverly, to kick us off. Rob is our NSF Program Officer, whom we all know and love. Take it away.
Awesome. Thank you, Susan. Let me just share my screen here. And all right. All right. Good morning, good afternoon, everyone. My name is Rob Beverly. I am a program officer within the NSF Office of Advanced Cyber Infrastructure, and I'm delighted to be here to welcome everyone to the Cybersecurity Summit and also give a few words of perspective and talk about some of the work that NSF is doing in this space. So really the talk goals here is just, again, to motivate why we're all here, spend a bit of time talking about the importance of cyber infrastructure, cybersecurity, and then talk about some of the complementary efforts that are ongoing within OAC, and of course, take any feedback from the community. So on the left here, I have the NSF mission statement, which is always good to remember, right? So the mission statement of NSF is to promote the progress of science, to advance the national health, prosperity, and welfare, and to secure the national defense. Some of what this has manifested in recently has been some of the NSF big ideas, everything from harnessing the data revolution, things like navigating the new Arctic, multi-messenger astrophysics, understanding the rules of life, quantum revolution, things like this. And underpinning all of these big ideas is cyber infrastructure. And so it's really not an overstatement to say that cyber infrastructure is central and indeed essential to NSF's mission and its priorities, and furthermore is aligned with the US administration and congressional priorities. So within NSF is OAC, which is the Office of Advanced Cyber Infrastructure, which is part of CISE. And OAC is here to support and coordinate the development, acquisition, and provisioning of state-of-the-art cyber infrastructure resources, tools, and services that are essential to the advancement and transformation of science and engineering. And when we talk about cyber infrastructure, we imagine it quite broadly to encompass everything from computing, data, the software, the networking, and of course, the people to facilitate scientific discovery and innovation. And one of the core tenets we have at OAC is that we can't realize these science goals unless the cyber infrastructure is indeed secure, robust, and trustworthy. Within OAC and NSF more generally, we take quite a holistic approach to cyber infrastructure. So at the center of this picture is the R&E cyber infrastructure that needs to support scientific discovery. And at the left, we have some of our fundamental and applied security research programs. So for instance, we have the CC program that works on R&E specific security research. We have the SATC program that performs some of the fundamental security research in the agency. And these kinds of programs hopefully can tie into various security test and evaluation platforms. So an example of this might be the Fabric platform. Complementary to all of this is the CC STAR program, which is working on making campus networks more secure and robust. Complementary to that are efforts that are underway for workforce development. So we have things like the cyber training program. We also have the CSSI program. So CSSI is working to make scientific software more sustainable and robust. And then last, we have some of our centers of excellence that are involved in best practices and engagements. So things like CI Compass. Most recently, we have the MSCC, the Minority Serving Cyber Consortium, which we're quite excited about. And then, of course, the Trusted CI Center of Excellence. So we employ a multi-pronged strategy, again, to try to support this scientific discovery mission. So now that we've talked a bit about why we're here, I want to spend a few minutes talking about some of the challenges of securing cyber infrastructure for the R&E community. So when we look at the programs that cyber infrastructure supports, they're quite varied and often quite complex. So we talk often about cyber infrastructure. We're talking about large instruments that may be producing big data. This big data often requires big compute, and it's often that these projects involve scientists that are highly collaborative, that are working perhaps in different specializations, and they're doing it both logically and physically distributed and widely distributed across infrastructure that has to be available, it has to be up, and it needs to ensure the integrity of the workflow, all while being easy to use, hopefully, and also while trying to, in some cases, adhere to various regulatory or policy requirements. And so this is a complex space. And the thing that I think we can all appreciate is that there's security issues that sort of run the gamut across all of these challenges. And that's why we need this secure infrastructure. So within OAC, when we think about security, we'd like to think of it as an enabler rather than an obstacle. So for instance, we're interested in how to keep this cyber infrastructure up and running and available, how to keep maintain the integrity, the authenticity, and the trust in the data and the cyber infrastructure, and how to enable data sharing and collaboration. And so these feed into some of our core tenets of trying to ensure that the community and cyber infrastructure can support production science, that it can support reproducible science, and that it can support collaborative science. And what we really don't want, and I'm sure we'll have a chance to talk about later in the summit, are headlines like this, where various HPC is co-opted for nefarious purposes, or even worse, I've generated my own fake headline here, where we might imagine a future where some scientific data is held ransom, and perhaps it's not possible to recover from that. This would have a very negative impact on the science mission, and these are the kinds of things that would be bad. So when we look at R&E security and cyber infrastructure from a more people-centric perspective and trying to think about who the vested parties are, of course, there's the scientists who benefit because they just want to do research. But then, of course, the scientists have colleagues, and the colleagues are interested in sharing data and resources. They're interested in things like reproducibility and integrity. Meanwhile, you have the management, and management is interested in things like reputation of the organizations and the research. They're interested in the finance. So these things have to be cost effective. Then you have the research office. The research office is interested in, for instance, protecting the intellectual property of the work. And then you have the information technology professionals who may be interested in making sure that the cyber infrastructure is available and isn't doing harm or causing harm. And then last, the public is also a vested party in this picture, where the public needs to have trust in science. So all of these different vested parties and all of these challenges lead to somewhat of an asymmetric situation. And this, of course, is why cybersecurity is still so important to do research on and still so important to make progress from a production standpoint. So within all of these different programs that NSF is supporting, I wanted to take a few minutes to highlight some of the work that we've recently been supporting within the CC program and expose the community to some of that exciting research. So CC is the Cybersecurity Innovation for Cyber Infrastructure Program. This was solicitation 21512. CC, its goal was to support applied research that would secure science data, workflows, and infrastructure. Its further goal was to develop, deploy, and integrate solutions that benefit the broader scientific community, and really wanted to operationalize emerging cybersecurity techniques into the science CI domain, while also developing new and perhaps bespoke cybersecurity approaches that might be specific to science CI domains and the requirements and constraints therein. The proposals were due earlier this year in January, and we have a planned solicitation for FY22, although it's not yet available or on the street. So within the CC program, there were 3 areas. The first area was what we called the usable and collaborative security for science. And this targeted applied research that would facilitate scientific collaboration, adopt security into scientific workflows, and do all of this while trying to overcome some of the security and usability obstacles that are inherent in data and resource sharing. The second area was something that we were calling the reference scientific security data sets. And the idea here was to really try to create some canonical science workload data sets that could be used by researchers to understand how to better secure these systems. So the idea was to capture science-specific workflow and workload behaviors and develop these data sets that could facilitate techniques that would help secure science cyber infrastructure. And then the last program was what we were calling the Scientific Infrastructure Vulnerability Discovery. And in this area sought applied research that would recognize some of the unique ecosystem of the scientific cyber infrastructure, proactively discover vulnerabilities and weaknesses therein, and do all of this while, of course, considering some of the ethical and operational concerns that are out there in doing this kind of work, as well as leveraging existing testbeds and frameworks. So in FY21, we awarded approximately $5.5 million. And I wanted to, again, to take a moment to highlight some of the programs and exciting work that's being done within CC. So the first is some work from a PI, Bloom. This is an interesting one where he is working on hardening a particular RTOS, or a real-time operating system that's used in a very domain-specific context. It's used by the physicists. This is called EPICS, and EPICS, he is working on taking this bit of cyber infrastructure and hardening it in various ways, both doing static analysis, dynamic analysis, and some other techniques. So this is a great example of how some of this bespoke science software CI is getting hardened and made more robust. Stephanie Forrest at the University of Arizona has some very cool and interesting research working with some domain scientists looking at wastewater epidemiology. Of course, wastewater epidemiology has been a big hot thing, both with COVID as well as in some other areas. And they're looking at taking some of these emerging security primitives for doing data sharing of encumbered data. So things like homomorphic encryption, differential privacy, federated learning, a bunch of these different techniques. They're working on taking these things to production, getting it in the hands of scientists so that they can work on this data and share this data across domains. At University of Virginia, Jack Davidson is working on the Helix program. This will actually be part of the Accord platform at University of Virginia and benefit scientists and domain scientists across the state of Virginia. This work is interesting and comes out of some of the Cyber Grand Challenge DARPA work that he and his colleagues have been doing, where they're creating science and science virtual machines and containers that are available in an app store type fashion. The idea here is to create these such that they have binary diversity, so that an attack that might work against one application, VM, or container does not work against a different VM, even though it's functionally equivalent and has the same capabilities. And this, again, is being done jointly with Accord and is being rolled out to some of the domain scientists to make their work more secure. At the University of Chicago is the Zotero project. This one is also looking at providing containers for cyber infrastructure. Some of the interesting things that they're doing here, in addition to vetting the containers and making it easier for scientists to easily use these containers that have the functionality that they need, they're creating persistent identifiers for these containers, a DOI, a document identifier. And this enables things like reproducibility, which is core, again, to science, as well as traceability. So when there is a particular vulnerability, folks can trace it back to the container and track down that vulnerability. And this is just part of what Zotero is doing, but it's some pretty exciting work that they're involved in. We're continuing to support the open science chain. This is work out of UCSD. This is working to try to address some of the challenges of how do we, again, do trustworthy and reproducible science. So it's trying to do this while using and leveraging blockchain primitives. And the idea here is to capture some of the metadata that these projects and actual data that these projects are generating such that it can be validated and verified by other scientists. And they're extending some of this to work on various kinds of private data sets and other kinds of access restrictions. At University of Utah is some exciting work where it turns out that there's some very specific vulnerabilities that can emerge within HPC simply due to the configuration of different software stacks and the sort of interactions between these different software stacks. And so they're working, this is a very tough problem, and they're working on how to do some detection in an automated fashion of these HPC vulnerabilities. And again, they're doing this in a production capability. Later today, I think we're hearing some from Jim Basney and some of his team talking about some of the work on authorization. Of course, this is extending some of the work of the CyTokens project. And this is a project called CyAuth. And this is working to, again, ensure essentially broadly interoperable authentication. And so, we view this as sort of one of these unsung heroes of doing secure sharing of cyber infrastructure. It's one of these things that is essential, but really is crucial to the domain scientists to ensure usability, to ensure sharing of resources, so on and so forth. So I think we'll hear more from Jim and his team later. And then Carolyn Ellis has been doing some very nice work in trying to build up a community that understands how to support regulated research and how to do this in a cost-effective and scalable way, all the while understanding that every organization and every university is different, right? So as some of the regulations become more restrictive and more cumbersome for researchers and their institutions, how can we actually support things like CUI research and be compliant when doing it? So she has been doing some cool work on this. I also wanted to mention some ongoing work from Justin Kapos and his group at NYU in securing the software supply chain. We've heard a bunch about software supply chains in recent years, and even more recently this year. There's been some fairly significant attacks, but this has been a persistent threat within the community. And as folks are probably well aware, there's multiple places in which an attacker might compromise the software supply chain. So there's been ongoing work from Justin over the years, starting with things like TUF, the update framework, to In Toto. In Toto is a project that NSF has supported to secure the entirety of the software supply chain, everywhere from the code stage, the test stage, all the way to the build, packaging, and distribution stages. And even more recently, Justin and his team have been involved in securing the Python software supply chain, which is pretty cool. If anyone, as you I'm sure are all aware, Python is widely used within the scientific community. And if anyone has ever done a pip install, believe it or not, none of that has any integrity, authenticity, or really any security guarantees. So he and his team have been working to fix that and to change that. So all of these little pieces help make the whole system more robust. And then last, I would be remiss not to mention a very recent award that just hit the street. This was out of our office. This was the MSCC, or the Minority Serving Cyber Infrastructure Consortium. This is OAC's newest center of excellence, and this is building a community of practice within the cyber infrastructure community for minority serving institutions in particular. And they bring both unique expertise as well as opportunities to the table. And of course, cybersecurity is a piece of all of that. So that was a whirlwind tour of some of the things that NSF values, some of the things that we view as important to cyber infrastructure, cybersecurity, and some of the work that we have been supporting that may be complementary and that folks may wish to consider within their own research or within their own organizations. So I definitely wanted to leave some time for questions and let folks get on this summit. I think there's some really exciting things. For more info about OAC, we have this somewhat cumbersome link here, but of course you can Google for OAC, and we're always very excited to get input from the community. We're interested in what OAC is doing right, what we could be doing better, and what we should be doing. We're also, I should mention, always interested in folks to serve on panels. So please contact us anytime. So my email is here, rbeverly@NSF. And I work very closely with my colleague, Kevin Thompson, whom many of you know. His email is here as well. So please feel free to reach out and contact us at any time. And again, delighted to see what happens here at the Cybersecurity Summit.
Thank you so much, Rob. I'm going to let it sit for about 30 seconds to see if anybody has questions, and they're just typing slowly. Oh, we have one. Anonymous asks, what cybersecurity related questions or requests do you most often receive from your NSF colleagues?
Right. So the yeah, so that is so that's a great question. So the kinds of things that we most often receive from colleagues at NSF are really along the lines of how do we do this? How do we get this down to the domain scientists? How do we sort of bridge these worlds? So often it's the case that cybersecurity is viewed as an obstacle, and so some of the practices and procedures that the domain scientists want to follow, they often don't take cybersecurity to heart. And so, the message that we have had at NSF, and my colleagues before me have been pushing for some time, is again really to view this as more of a carrot rather than a stick, right? So things like, of course, you can relate much more strongly to the domain scientists when you tell them, oh, hey, what happens if all your data disappears? Or, how can you trust that the data that you're getting from this organization is in fact authentic and hasn't been modified? How can you ensure that you can log into your cyber infrastructure and that it's available? So those are the kinds of things that we get from our NSF colleagues often. Now, often it's the case that some of these cyber infrastructures are have very unique requirements, right? So if you think about things like some of the polar expeditions or some of the navigating the new Arctic or any of these kinds of things, they operate in very constrained situations and environments. So often we get questions from our colleagues about how on earth do you do cybersecurity in these kinds of domains? So those are some of the things that we get from our NSF colleagues. Yeah, so I'll leave it at that.
Thank you so much. So we have one more question and about 3 minutes to answer it. Do you see how the cyber training program could work in collaboration with existing OAC sponsored projects?
Right, thanks for the question. It's I should emphasize, and I probably didn't emphasize it enough, just how important workforce development is to OAC and the NSF more broadly. This is something that is of high priority to us. We certainly recognize that many of the problems that we're facing are human constrained, and that we really need to develop both expertise on the cyber infrastructure side as well as the cybersecurity side. So we are very keen for things like workforce development, cyber training, and all of this to be complementary to all of the existing OAC sponsored projects. Trusted CI, of course, has several programs operating in this space. All of this is very important. So we do see this all fitting together.
Thank you so much.